That's all I have. Okay, so the different types of electromagnetic radiation, probably jot that down in your note card. And then these two things go along with that. Okay, frequency and wavelength. Okay, so kind of in the green and the purple, I put, with regard to the most energetic gamma rays, they have high frequencies and short wavelength. And then radio waves have low frequencies and long wavelength. And then up there, if I go for too fast, let me know.
You're good.
In the upper corner up there, I went ahead and wrote down kind of what an atom looks like. So, and atoms have a nucleus, and the green are the protons, and the purple are the neutrons. They're in the nucleus. Electrons are outside. And then kind of related to that, we have kind of some terms with regard to an atom. The atomic number in red, there's the number of protons. And then also atomic number I wrote in green there. And the atomic number of an atom, number of protons, defines what element an atom is. And then atomic mass number is actually in blue at the top there, where it says atomic mass number. You add together the protons and the neutrons. And then there was a slide that said the 3 different things that can happen when light hits matter. Light can be transmitted by the matter, light can be absorbed, light can be reflected or scattered. Kind of ringing some bells. And then I brought in a picture from the internet to kind of talk about the 3 types of spectra, so from the top down. So there's continuous, and then there is emission line, and there's absorption line. So a continuous has no lines. Emission line has bright lines and a back, and then absorption lines is the rainbow, and you see the dark lines. And then also related to that is this one underneath it where it said electrons transitioning between energy levels. So here in kind of green and red, I said what electrons are doing.
Okay.
So these electrons are falling back after being excited to emit the light, and here electrons are being excited up to take out the light. And then I put up a bunch of stuff, kind of the red and green and kind of this down here are talking about the 2 types of telescopes. So there's a reflecting telescope that uses mirrors, and a refracting telescope that uses lenses. That's lenses there. And then down here I kind of draw 2 really crude drawings of the telescopes. Isn't that terrible?
I get the idea.
Good. I bet you do. And here's my mirror back here for my reflecting telescope. And then here's my lens here for my refracting telescope. And then one of the things they have in common is they gather the light to a point. They gather the light to a point, and that point is called the focal point. And then the angular resolution of a telescope is just talking about your ability, or I put able to resolve detail. Angular resolution, able to resolve detail. And then the next one I kind of put over here, down here. And it says, this is talking, redshift and blue shift have to do with a source moving. So with the redshift, the source is moving away from the observer with the redshift. And then if you're looking at spectral lines, with the redshift, spectral lines are going to be longer wavelengths. And then the blue, the source is moving towards the observer, and the spectral line is going to be shorter wavelengths. And the last thing, telescopes in orbit, I put there at the top there. The kind of in the purple up there, telescopes are in orbit, because now if we can avoid light pollution if we orbit the Earth, and we can avoid Earth's atmospheric turbulence, And also that third one is there, that the Earth absorbs energy, or the Earth's atmosphere, excuse me, absorbs energy as we look at.
The red and the blue is the only thing that like really like stopped me, but like, cause I get them mixed up, but okay, so the red goes away, so, can I think of it like, red basically is heat, where like stuff is hot, like it's just like you radiate heat, so it like goes away from your body, if that makes sense.
Maybe.
Like, that probably sounds really dumb, but when I'm hot, I'm like, oh my gosh, do you feel my heat? You know what I mean? Okay.
I think so.
Okay, so I'll think of it like that because my face gets red.
Yeah.
And then,
And blue things kind of cool down and they're coming towards you. I think that would work.
most complicated way to explain it.
Oh. There it goes. Okay. So the solar nebula is what our solar system was formed from. And then kind of related to that, I have it in green and then red, kind of like the solar nebula before the sun was there, formed and our planet was formed. What it was, we said it had 4 things in it. It had hydrogen and helium, that was most of it. And then it had the water, methane, and ammonia, hydrogen-containing compounds. And then it had rocks and metals. And the 3 and 4, they were least abundant, least present. And then the nebular theory, which, okay, that our solar nebula kind of collapsed or drew together. And the thing over there in orange, because it kind of came together, it spun faster, just like a skater who brings in her arms, spins faster, and it got hotter. Conservation of energy and momentum. And then I think I go on to I think just a minute. Then I go on to my next. Too far. Oh, there it is. Okay. Okay, then. Okay. Now I don't have any stops here, so my thing about system of moons forming around the Jovian planets, basically the purple is kind of thinking of inside the purple, in the middle of the purple. I didn't draw it, but kind of think of Jupiter in there. And we had a figure where basically it kind of showed swirliness around Jupiter, and that swirly material early on in the formation of our solar system, that's what gave, that accretion disk is what gave Jupiter its moons. The next one, the anomalies of our solar system, let's see. Bless you. So there I wrote, like, for instance, anomalies means what doesn't make sense. That said Earth's large moon. I know it's hard to read. Earth's large moon. We got a larger moon than we should have. And then Uranus is crazy tilt. The word anomaly just means it makes you kind of scratch your head why it is. And then I'm not sure 3 really is an anomaly after I think about it. The fact that we have stuff out there, you know, kind of where Pluto is, beginning what we call the Kuiper Belt. Okay. The next one, the two types of planets, I bet you'll do good with that. We have rocky and gaseous. The rocky planets are smaller, the gaseous planets are larger. They differ in their composition that we just talked about tonight. And then also composition and surfaces, like the surface of a gaseous planet is gas, the surface of a rocky planet is rocky. And then accretion, I have planetesimals getting larger for accretion. And then frost line separates the terrestrials from the Jovians. And I kind of summarized in green there that rock was able to condense at those higher temperatures closer to the sun. And the last term there, I kind of drew, that's our solar system, so the purple is, sorry, go back. The purple is the plane of the ecliptic. There. The purple is kind of how the planets orbit the sun, and then those little dots out there that are kind of peach colored, that's the Kuiper belt. So Kuiper belt is kind of in the plane of the ecliptic, kind of out here where Pluto is. It's the Kuiper belt. And then the Oort cloud is also Crumblies, but actually it is further from the sun and it's spherical.
I'm gonna do it. Just be yellow dots around it.
I like that.
Okay.
Very good.
So,
Chapter 7. Okay, plate tectonics. Chunks of crust floating on mantle. And then I drew a little picture for the crust, mantle, lithosphere, and outer core, but kind of beginning with the inner core. Don't worry about the two types of cores, the inner and the outer, but just know there is a core. And then I drew the line for the mantle, okay, and then I drew my little crust, okay, and then the lithosphere is actually the crust in the top part of the mantle. And then convection, I kind of drew down below there. And I said the core is hot, and so you kind of see the blob of liquid mantle rising, okay, and then it cools, and then it falls back down. That's convection with the hot core. And then the blue is planetary differentiation, okay. Heavy, dense material sinks, planetary differentiation. And then surface erosion we talked about tonight. Actually, plate tectonics or tectonics is kind of like a way to get our surface eroded. But probably more common, we think of wind erosion, water erosion, glacial erosion. I didn't write that one, but that would be a good one. And then Mercury has those thing called scarps, and they were formed during cooling. It's in blue there. Or actually, scarps is in blue, and then red is during cooling. And then the Caloris Basin, I think you just need to know that it's a feature, Caloris Basin is a feature on Mercury, the planet Mercury. And in green, the Valles Marineris is that scar on Mars. And I went ahead and added in green, it's on Mars near the equator. And then tonight I wrote on a slide, because it wasn't on a slide, but Venus is, we know Venus's map because we've used radar from satellites that are orbiting Venus, because we can't see through the clouds. And I think that's going to be probably extra credit on the test. So greenhouse gases trap outgoing heat. And then I went ahead and listed some greenhouse gases. CO2, H2O gas. And then I went to flowing water and came back to how Mars lost its atmosphere. But flowing water, Mars once had this, because we can see it in the erosion. So then I go back in green and say, how did Mars lose its atmosphere? And I kind of walk stepwise through it. I said, first it cooled down, and then it lost its magnetosphere, and then the sun, it was at the mercy of the sun. Okay, so in green there, I say it cooled quickly because it's smaller. It lost its magnetosphere because it was cool, and then the wind blew it being the atmosphere. And then Phobos and Deimos, they look like potatoes, and they orbit Mars. They orbit Mars, Phobos and Deimos. And the red color of Mars, I didn't see it in my notes this semester, so that might have to be extra credit too. But Mars is red because of basically rust or iron oxide. And one last term, magnetosphere or magnetic field. Okay, I put it's protective, and planets must have liquid core. And then as far as which planets have a magnetic field, I put Earth has a big magnetic field, and Mars has a wimpy magnetic field. And then someone during review tonight said, well, how the terms magnetic field and magnetosphere are related, and then in yellow I said they were the same thing. So last chapter, and it's a short one. Yay! Oops, pause. So, kind of the first one is self-explanatory, that all those Jovians have rings and moons. And then the second one, looking at the densities, in blue I said Saturn's density is less than that of Jupiter. And then in green I say Jupiter has lots of material compacting it down, kind of like the pillows. And for Io, that closest moon of Jupiter, it's heated so it can have volcanic activity because of what they call tidal flexing. And then I go on to say, I'd say if you kind of think of a stress ball, you're squeezing a stress ball, it gets hot. And the tidal flexing, the squeezing and deformation comes from gravitational pull of passing moons. And composition of Saturn's rings. Oh, sorry, I skipped down to green. So it's methane that makes Uranus and Neptune blue. And composition of Saturn's rings, and purple there. They're reflective because basically they are ice and ice-coated rock. And then Triton is a moon that orbits Neptune. And there in red I went ahead and oh, drat. In red, I said Titan is a moon we said tonight that orbits Saturn. And Titan is the moon that we actually landed on, or somebody landed on, the spacecraft. Almost. Okay. Okay, so Galilean moons, just probably jot them down, and I think I misspelled Ganymede. But the Galilean moons orbit Jupiter, and it wouldn't hurt to go ahead and write them down. And then the last one, tectonics of icy moons, I drew kind of liquid water instead of liquid mantle, and then crust floats around on that liquid water.
Yay! I just got like creative session done in like